Whenever some external system of forces act on a body, undergoes some deformation, as the body undergoes some deformation and set up some resistance to the deformation, the resistance per unit area to deformation is called stress. The unit of stress in SI units is the any one of these. The deformation per unit length is called strain. The unit of strain is no units. Strain is equal to delta L by L. When body is subjected to equal and opposite pushes, as a result of which the body tends to reduce its length, the stress and strain induced is compressive. True. When a body is subjected to equal and opposite pulls, as a result of which body and extend its length, the stress and strain induced is tensile stress. Tensile strain. Generally, fan ban जाओगे. When a body is subjected to two equal and opposite forces acting tangentially across the resisting section, as a result of which the body tends to shear off across the section, the stress and strain induced shear stress, shear strain. Which of the following is the proper sequence? Proportional limit, elastic limit, yielding failure. Hooke's law holds good up to elastic limit. Whenever a material is loaded within elastic limit, stress strain is directly proportional to. The ratio of linear stress to the linear strain is called as modulus of elasticity. The unit of modulus of elasticity is same as those of stress, pressure and modulus of rigidity. When a change in length takes place, the strain is known as linear strain. The change in length due to tensile compressive force acting on a body is given by PL by AE. The modulus of elasticity of a mild is approximately equal to 210 kN per meter square. Millimeter square. Young's modulus may be defined as the ratio of linear stress to linear strain. Modulus of rigidity may be defined as the ratio of shear stress to shear strain. The unit of Young's modulus is same that of the stress is true. Two bars of different material, same size, subjected to same tensile force. The bars have unit elongation in the ratio of 2:5. Then the ratio modulus of elasticity of two materials will be 5:2. When a bar of length L, diameter D is fixed the upper end engaging freely, the total elongation produced in the bar due to its own weight is the WL square by 2E. The deformation of a bar under its own weight is the deformation of the body sum subjected to direct load equal to weight of the body is the half. The elongation of a conical bar under its own weight, that a prismatic bar in the same length is the 1/3. The length of a conical bar is L, diameter D, weight per unit volume W is fixed at its upper end, hinging freely. Elongation of the bar under action of its own weight will be dash WL square by 6E. Strain rosetters are used to measure linear strain. A bar of length L meter extends by L mm under a tensile force of P. Strain produced in the bar is 0.001 L by L. The extension of a circular bar tapering uniformly from diameter D1 at one end is the diameter D2. The other end, the subjected to an axial pull of P is given by delta L equal 4PL by pi E D1 D2. The extension of a circular bar tapering uniformly from diameter D1 one end to diameter D2 at the other end, the subjected to an axial pull of P is the extension of a circular bar of diameter root of D1 D2 subjected to the same load is the equal to. The ultimate tensile stress for a mild steel is the ultimate compressive stress is the more than the maximum stress produced in a bar of tapering section is at a smaller end. Modulus ratio of the two material, the ratio of their modulus of elasticity. The shear modulus of most material with respect to the modulus of elasticity is less than half. A rod is enclosed centrally in tube and assembly tightened rigid via washers. If the assembly is subjected to a compressive load, then both rod and tube are under compression. A bolt is made up to pass through a tube and both of them are tightly fitted with the help of washers and nuts. If nut is tightened, then the bolt is under tension and tube is under compression. When bar is subjected to change of temperature and deformation is prevented, a stress induced in the bar is as thermal stress. A steel bar of 5 mm heated 15 mm for expansion, the hard will induce no stress. When bar is cooled at minus 5 degrees centigrade, will develop a tensile stress. A bar, a copper and steel from composite system which is heated to a temperature of 40 degrees centigrade. The stress induced in the copper bar will be compressive. The thermal stress in the bar is proportional to the change in temperature directly. The thermal stress upon a cross-sectional area of the bar does not depend. If there is a fail the temperature composite body, then number of having great coefficient of linear expansion will be subjected to compressive stress is the false. The thermal or temperature stress is the function of all of this above. When a circular ball tapering uniformly from diameter d1, one end is the diameter d2, other is d, and is subjected to increased temperature, thermal resistance induced to alpha T Ed by d2. Which of the following statement is correct? Stress is directly proportional to strain within elastic limit. The deformation of a bar per length of the direction force is known as linear strain. Every direct stress always combined with strain is known as direction is opposite kind strain is every direction. At right angles its such strain is known as a lateral strain. The ratio of the lateral strain in the linear strain is called as Poisson's ratio. Poisson's ratio, the ratio of linear strain to volumetric strain, this is the false information. This is the equal to, and the Poisson's ratio for a steel varies from 0.23 to 0.27. The Poisson's ratio for cast iron varies 0.25 to 0.33. When a bar of length L, width B, thickness T subjected to pull of P, the length increases, width thickness decreases. The ratio of change in volume in original volume is called volumetric strain. When a bar of length L, width B, the thickness is subjected to push of P, its length decreases, width and thickness increases. The volumetric strain is the ratio of the change in volume to the original volume. When rectangular bar of length, width, thickness subjected to axial pull of P, then linear strain is given by B equal P by BTE. When rectangular bar of a length L, width B, thickness T subjected to axial pull of P, the volumetric strain is E of 1 minus 2 by M. When a body is subjected to three mutual perpendicular stress of equal intensity ratio, the direct stress to the corresponding volumetric strain is known as bulk modulus. The relation between the Young's modulus and bulk modulus K is given by the K is equal to ME by 3 of M minus 2. The ratio of bulk modulus Young's modulus for a Poisson's ratio of 0.25 will be at 2 by 3. When a cube subjected to three mutual perpendicular tensile stress equal intensity, the volumetric strain is 3 sigma by E 1 minus 2 by M. The relation between modulus of elasticity E modulus of rigidity C is given by C is equal to ME by 2 of M plus 1. If the modulus of elasticity material is twice its modulus of rigidity, then the Poisson's ratio of the material is equal to 0. Correct. The relation between the Young's modulus and shear modulus and bulk modulus K is E equal to 9 Kc by 3K plus C. The ratio of shear modulus, the modulus of elasticity for a Poisson's ratio 0.4 will be 5 by 14. If the modulus of elasticity for a given material twice the modulus of rigidity, then the body modulus equal to 2C by 3. The Young's modulus of material 125 GPa. Which of the following statement is wrong? The bulk modulus is the ratio of linear strain. This is the false information. With the elastic limit, shear stress is shear strain. This is directly proportional to shear modulus is the ratio of shear stress to the shear strain. A localized compressive state, the area contact between two members is known as crushing stress. The change in length due to tensile or compressive load C PL by AE. The extension of circular bar tapering from D1 D2 is D 4 PL by pi E D1 D2. The volumetric strain of rectangular bar is this E of 1 minus 2 by M. The relation between Young's modulus E and bulk modulus EA ME by 3 of M minus 2. The relation between modulus of elasticity and modulus of rigidity the ME by 2 of M plus 1. The maximum diameter of the hole that can punch from plate maximum shear stress 1 by 4th of the maximum crushing stress of punch is equal to 40. The planes which carry no shear stress are known as principal planes. True. When a body is subject to direct tensile stress in one plane, the normal stress in the oblique section of the body inclined and angled to the normal, the section is the sigma cos square theta. In the above equation, the normal stress oblique section will be maximum, then theta will be 0 degrees. The direct stress across the principal plane is known as the principal stress S. When a body is subjected to direct tensile stress in one plane, the tangential shear stress on the oblique section of the body inclined at an angle theta normal. The section is the sigma by 2 sine 2 theta. The resultant stress on an inclined plane which inclined at an angle theta normal cross section of a body which is subjected to direct tensile stress in one plane is sigma cos theta. When a body is subjected to direct tensile stress in one plane, the maximum normal stress occurs at a section inclined to the normal of the section is 0 degrees. When a body is subjected to direct tensile stress, the maximum normal stress is equal to the direct tensile stress is agree. A body is subjected to direct tensile stress in one plane, the shear stress is the maximum of section inclined at the normal of the section is the 45 and 135 degrees. When a body is subject to direct tensile stress in one plane, the maximum shear stress and the maximum normal stress is the one of principal plane is the plane which shear stress is 0. When a body is subject to direct tensile stress in one plane accompanied by a simple shear stress, maximum normal stress is sigma x by 2 plus 1 by 2 sigma x square plus 4 tau square xy. When a body is subjected to direct tensile stress in one plane accompanied by a simple shear stress, minimum normal stress is sigma x by 2 minus 1 by 2 root of sigma x square plus 4 tau square xy. When a body is subjected to direct tensile stress in one plane accomplished by a simple shear stress, the maximum shear stress is the 1 by 2 sigma x square plus tau x square xy. And for this above problem, okay. When a body is subject to biaxial stress, direct stress sigma by 2 mutual perpendicular planes, combination by a simple shear stress, maximum normal stress sigma x plus sigma by 2 plus 1 by 2 sigma x by 2 whole square plus tau square xy. When a body is subjected to biaxial stress, direct stress, two mutual perpendicular combination by the simple shear stress, the minimum normal stress is the sigma x plus sigma by 2 minus 1 by 2 sigma x minus sigma by whole square plus tau square xy. When a body is subjected to biaxial stress, direct mutual perpendicular planes accompanied by shear stress, the maximum shear stress is 1 by 2 sigma x minus sigma by whole square plus 4 tau square xy. And the minimum shear stress is the algebraic difference maximum and minimum normal stress is the one of this one is the more circular circle, two unequal and like principal stresses acting of your body across two mutual perpendicular planes. The normal stress on your oblique section making an angle theta minor principal plane is given by this is the OQ. The tangential stress is given by PQ. The resultant stress is given by OP. The radius of Mohr circle is equal to half the difference of two principal stresses. The maximum shear stress equal to 1 of Mohr circle is the radius. Mohr circle is used to determine the stress on your oblique section of your body subjected to all of the above. Mohr circle is used to determine the stress of oblique section of when a body is subject to direct tensile stress to mutual perpendicular direction accommodation by a simple shear stress, Mohr circle within the circle radius is taken as 1 by 2 root of sigma x minus sigma y whole square plus tau square tau x square. In Mohr circle, the center of circle from y-axis taken as sigma x plus sigma by 2. The extremities of any diameter of Mohr circle is represent normal stress on a plane at 45 degrees. The maximum shear stress is equal to the radius of Mohr circle is correct. The energy stored in a body when strained within the elastic limit is known as strain energy. The total strain energy stored in a body is termed as resilience. The proof resilience is the maximum strain energy which can be stored in a body. Yes. The proof resiliency per unit volume of the material is known as the modulus of resilience. This is the true. Strain energy is the dash energy stored in a body when strained within elastic limit. The strain energy stored in a body suddenly loads the strain energy when the same load is applied gradually is the 4 times. Resilience is the none of the above. The total energy strain energy stored in a body is called proof resilience. Disagree. Modulus of resilience of the proof resilience per unit volume of a material is the correct. The strain energy stored in a body when the load gradually applied as sigma square by V by 2E. The stress induced in a body when suddenly loaded in the stress induced in the same load is applied gradually twice. The strain energy stored in a spring when subjected to maximum load without suffering permanent distortion is known as proof resilience. The capacity of strained body is doing work. The removal of the string force is called as resilience. Which of the following statement is correct? All of the above. The strain energy stored in a body due to shear stress is tau square by 2c into v. In beam which fixed in one end and free and other end is called cantilever beam. A beam supported at the both ends is not simply supported beam, is fall. A beam extending beyond the support is called as overhanging beam. The beam encasted at both ends is called as fixed beam. A beam supported one more than two supports is called as continuous beam. A cantilever beam is one which is dash fixed at one end and free at the other end. A simply supported beam is one which supported more than two supports is a false information. An overhanging beam must overhanging on the both sides is the right. A fixed beam is one which is fixed at its end both. A continuous beam is one which is supported one more than two supports. Concentrated load is one which does acts and point on the beam. A load which acts as point in the beam not called uniformly distributed. Agree. A uniformly distributed load may be assumed to behave like point at the center of gravity. The load for all sorts calculation, right? A load which is spread over a beam in such manner that varies uniformly over the whole length of beam is called as uniformly load is varying. The shear force a point on a beam in the algebraic of the forces at the side of the point sum. The bending moment at the point of beam in the algebraic, the moments of the point is the sum. The bending moment is section maximum where shear force is changing sign. When a load on the free end of cantilever beam is increased, failure will occur at the fixed end. The bending moment at the free end of a cantilever beam is 0. A cantilever beam of length L carrying a point W at the end of free, which of the following is correct? This is the diagram. A is the shear force diagram and C bending moment diagram. This curve is this one. C is this is the WL. Okay. When cantilever beam is loaded with a concentrated loads, the bending moment diagram will be a dash inclined straight line. The bending moment diagram for a cantilever beam loaded with a uniformly distributed load W parabolic curve. This is the correct. The maximum bending moment of a cantilever beam in the shown figure, the fixed end. The shear force at a cantilever beam is showing W throughout its length. The shear force of cantilever beam of length L carrying uniformly distributed load W per unit length is dash free end is 0. The shear force cantilever beam W length uniformly distributed load W unit length is at the fixed end is the WL. The shear force diagram cantilever beam is length carrying uniformly distributed load W per length will be dash and right angle triangle. The bending moment cantilever beam of a length L and carrying uniformly distributed load per unit length is at the free end is 0. The shear force bending moment is 0 at free end is cantilever beam is carries in a uniformly distributed load over the whole length. A bending moment of cantilever beam length L carrying a uniformly distributed load of W per unit length is the fixed end is the WL square by 2. The maximum bending moment is the shear force diagram cantilever beam length L carrying a gradually varying from the 0 free end W per length of fixed end is dash parabolic curve. The bending moment diagram cantilever beam of a length and carrying gradually load from 0 at the free end W per length at the fixed end is parabolic curve. This is the agree. A shear force of cantilever beam of length L and carrying gradually varying load from the at the free end W per length at the fixed end is at the fixed end WL by 2. The bending moment of a cantilever beam of length L carrying a gradually varying load from 0 at free and W per unit length of fixed end is the at a fixed point WL square by 6. The bending moment at the ends of a singly supported beam will be 0. Yes, the maximum bending moment of a simply supported beam of a span L carrying a point load W at the center of beam is WL by 4. The bending moment diagram for a simply supported beam loaded its center is an isoclone triangle. The maximum bending moment of a simply supported beam with a central point load lies on the point of a loading. This is the true. The shear force of a simply supported beam carrying a central load changes sign its a midpoint is the correct. The shear force in center of simply supported beam carrying uniformly distributed load W per length is 0. The bending moment in the center of simply supported beam carrying uniformly distributed load W per unit length is the WL square by 8. The shear force at the end of simply supported beam carrying uniformly distributed load per unit length is WL square by 2 at one ended minus WL by 2 in the other end. Shear force diagram simply supported beam carrying uniformly distributed load W per length consists of two right angled triangles. The bending moment diagrams for a simply supported beam carrying uniformly distributed load per unit length will be dash parabolic curve. A shear force center of simply supported beam with a gradually varying load is 0 at the both ends. W meter center is 0. The bending moment diagram simply supported beam the gradually varying loads from the 0 at both ends is W per meter center. WL by 4. This is the no. The maximum bending moment is simply supported with the gradually varying load from the 0 at the both ends W per meter center lies in the center of beam. This is the agree. A simply supported beam is gradually varying load from 0 B W per unit length is shown in the figure. The shear force B is equal to this diagram WL by 6. For the beam shown in the figure, the shear force at A equal to 4L by 3. For the beam shown in the force diagram, A and B is the parabolic curve. The maximum bending moment of the beam shown in the figure WL square by 9 root 3. The maximum bending moment for the beam shown in the distance of the end is the 1 by root 3. The point of contraflex is a point where the bending moment changes sign. When shear force at a point 0, the bending moment is at the point is maximum. In a simply supported beam carrying a uniformly distributed load W per length, the point of contraflex does not exist. When there is sudden increases or decreases shear force diagram, the 2 points indicate that the center is the point load at the 2 points. When the shear force diagram between the 2 points is inclined straight line indicates that the uniformly varying load between the 2 points is S. When the shear force diagram is a parabolic curve between 2 points indicates there is a dash uniformly varying load between the 2 points. When there is no increases or decreases shear force between 2 points indicates that the no change the bending moment between these points is true. Which of the following statement is correct? A uniformly distributed load spreads uniformly over whole length of the beam. This is the shear force at free end of cantilever beam carrying uniformly distributed load is dash 0. The bending moment at a fixed end of a beam is the maximum. The maximum bending moment of a simply supported beam carrying uniformly distributed W per unit length is the WL square by 8. The bending moment at the center of simply supported beam with gradually varying load from 0 at ends W per meter center is WL square by 12. A beam where shear force changes sign, the bending moment will be dash maximum. The point of contraflexure occurs in a overhanging beams. The bending moment in a section tends to bend, deflects the beam and internal stress resists bending. The resistance offered by the internal stress to the bending is called bending stress. The assumption generally made in the theory of simple bending is that is all of the above. In a simple bending theory, one of assumption that the material has been isotropical. This assumption means that the elastic constants are same in all directions. In a simple bending of beams, the stress in the beam varies linearly. In a simple bending theory, one of the assumption is that of the plane section before remaining plane after bending. The assumption means that the strain proportional to the distance from the neutral axis. A rectangular beam subjected to bending moment is shown in the upper layer of the beam will be retention. This is the fall. The lower layer of the beam this is in tension. Lower layer of the beam tension. The layer of center of gravity in the beam is the neither in tension nor in compression. When a beam is subjected to bending moment, the strain layer is the distance from the neutral axis directly proportional to. The bending equation is m by I sigma by E by R. A section of beam is said to be pure bending is subjected to constant bending moment is zero shear force. When a beam is subjected to bending moment, the stress at any point in the distance the point from the neutral axis directly proportional to. The line of intersection of a neutral layer at any normal cross section of the beam is called as neutral axis. This is the true. The neutral axis of a cross section beam is that axis of which a bending stress is dash 0. A neutral axis of the symmetrical beams does not passing through a centroid of the beam. This is the disagree. The section modulus Z of a beam is given by I by Y. The section modulus of rectangular section about axis through center of gravity is the BD square by 6. The bending stress in a beam is section modulus inversely proportional to the section modulus of circular section about axis of center of gravity is the pi d cube by 32. If the section modulus of beam increases, the bending stress of the beam will be decreases. For a given stress ratio of moment of resistance of beam of a square cross section when placed with two sides horizontal, the moment of resistance with the diagonal horizontal is the root 2. A square beam and a circular beam have the same length, same allowable stress and the same bending moment. The ratio of weights the square beam is the circular beam is 1 by 1.12. Two beams, one of circular cross section and other and square cross section, have equal areas of cross sections. When the beams are subjected to bending, square beam is more economically. In a beam of uniform strength, in bending stress developed in a constant and is equal to the allowable stress at every section of the beam. This is the true. When a cantilever beam is loaded at a free end, the maximum compressive stress is the developed at bottom fiber. A beam of uniform strength may be obtained by any one of these above. If the depth kept constant of a beam of uniform strength, then the width of varying in a pi proportional to m. A beam of uniform strength has same bending stress at every section. The bending stress in the beam is bending moment. This is the directly proportional to. At the neutral axis of a beam, the layers do not undergo any strain. The neutral axis of a beam subjected to stress 0. The neutral axis of a transverse section of a beam passing through the gravity section and is at right angles of the plane which the beam ends. On one end of side neutral axis of beam, there is tensile stress. On the other side of the beam, there is compressive stress. This is the right. In beam subjected to pure bending, the intensity of stress in a fiber, the distance of fiber from neutral axis is the directly proportional to. In a rectangular beam has length, width, depth. The length, width, depth is doubled. Then A elastic strength of a B will be compared to then A 4 times is there. The rectangular beam A has length L, width B, depth. Another beam has same length of the depth, width doubled. That the elastic strength of beam will be as compared to A doubled. A rectangular beam A length, A depth. Another B the same width, depth, length doubled that of A. The elastic strength of beam B will be as compared to them A 1 off. When rectangular beam is loaded, transfer the maximum tensile is developed as a top layer. When a rectangular beam is loaded, transfer the maximum compressive stress is developed on the bottom layer. When rectangular beam is loaded transversely, the zero stress is developed on the neutral axis is true. When a rectangular beam is loaded longitudinally, shear force developed on the top layer walls. At a neutral axis of a beam, shear stress is maximum. The maximum shear stress developed in a beam rectangular section is the average shear stress is the 1.5 times. The maximum shear stress developed in a beam circular section, the average shear stress is the 4 by 3 times. The ratio of maximum shear stress developed in a rectangular beam, circular beam of the same cross sectional area is 9 by 8. A beam of triangular section is placed with the base horizontal. The maximum shear stress occurs at mid of the height. The maximum shear stress of beam triangular section occurs the neutral axis is the correct. A beam of T section is subjected to shear force F. Maximum shear force will occur at neutral axis of the section. Which of the following statement is wrong? At the neutral axis of the beam, bending shear stress maximum. A featured beam is used to equalize the strength of the tension in compression. A rectangular beam of a length L supported two ends carries central point load W. Maximum deflection occurs at the center. A simply supported beam L carries point W at the point C shown in the figure. The maximum deflection lies between point B and C. For the maximum deflection at W, A square B square by 3 ELL falls. For beam of shown in the deflection C, the W A square B square 3 EIL. For a beam shown in the figure, the maximum deflection lies at L square minus A square by 3 from B. For a beam shown in the figure, when the load W applied the central load of the beam, maximum deflection is WL cube by 48 EA. A simply supported beam of length L loaded with uniform distributed load for the length of maximum deflection 5 WL equal 4 by 384 EA and lies center of lies. This is true. A simply supported beam, A length carries W, another beam loaded uniformly distributed load. So the total load of the beam, the ratio of the maximum deflection between beams A and B is 8 by 5. Okay, thank you. SOM first part over.